Let's take a look at this problem. Got f of x is equal to x squared plus 1 over x squared. Okay, I need a piece of paper here. Let me get one. There we go. Okay. Now our first thing we're going to do is find our domain. Well, we have a fraction. Whenever you have a fraction, you set your denominator equal to 0. So we got x squared equal to 0. We can drop the squared, and we just get x is equal to 0. Now this is the value that causes us problems. If I put 0 in here, we get 0 squared. You get 1 over 0. You can't have division by 0. So our domain is x cannot equal to 0. And I'll write this down as we go, because I got a feeling that this problem is a little bit harder, and it'll probably take more than room I have. Now our next thing is find the x-intercept. We'll plug 0 in for the other variable, so plug 0 in for y. So we got 0 is equal to x squared plus 1 over x squared. Now we want to solve this. This is a rational equation. The steps for solving a rational equation, besides get rid of parentheses, get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, the x squared, so that's our LCM. We'll multiply the 0 by x squared. We'll multiply the x squared by x squared. And we'll multiply the 1 over x squared by x squared. And these x squareds cancel. X squared times 0 is 0. X squared times x squared is x to the 4th plus 1. Now I want to take the 1 over the left side, becomes a negative 1. And x to the 4th I can rewrite as 4 over 1. Now we want to get x by itself, so we're going to raise both sides to a power equal to the reciprocal. Well, reciprocal is fraction flipped, so 4 over 1, and we'll raise both sides to the 1/4 power. So we've got negative 1 to the 1/4 equals x to the 4 over 1 to the 1/4. Now, since this is an even number up on top, that means we need to put a plus or minus on the other side. Well, if I put this back in radical form, it'll look like this. And over on this side, the 4's cancel, the 1's cancel, we got x. Well, our index is 4. And we can't have a negative number inside there, so that means that there is none. So there is no x-intercepts. Let me write that down. This one's domain, x-intercepts, none. Okay. Now for our y-intercept, you always plug 0 into the other variable. So I got y is equal to 0 squared plus 1 over 0 squared. 0 squared down here, 1 over 0 is undefined, so there is none. Let's see, y-intercept, none. Okay. Now D, vertical asymptote. Now if I see that I got a fraction here, I can merge these together into a single fraction. So we got f of x is equal to x squared over 1 plus 1 over x squared. I rewrote the x squared in fraction form by putting it over 1. Now I want to get a common denominator. Our common denominator, multiply these two together, would be x squared. Now our second fraction already has it. The first one, we multiply the bottom by x squared, so we have to multiply the top part by x squared. And that gives us x to the 4th. So that gives us x to the 4th plus 1 over x squared. Now for our vertical asymptote. Our steps for finding a vertical asymptote: factor the top, factor the bottom. The top might actually factor if we tried it, because we have two terms with a plus between it. So we'd try sum of 2 cubes, but it actually fails. 1 times 1 times 1 gives you 1, but nothing times itself 3 times gives you x to the 4th. But again, you know, it's of a form where we could try factoring. So factor top, factor the bottom, can't do that. Cancel if possible, can't do that. Vertical asymptote, set the denominator equal to 0, and solve it, and we get x is equal to 0. So that's our vertical asymptote. I'll write that down. Now that's why the domain is it doesn't exist at 0. It's also why we don't have a y-intercept, which we'll see in a graph. Okay, now we're still looking at our rational form, this right here. So the next thing, the horizontal asymptote, which one is that? That's E. Now our degree is our largest power of x. So degree of the top is 4, degree of the bottom is 2. When a degree of the top is greater, that means there is no horizontal asymptote. F, our slant asymptote. You have a slant asymptote when your degree of the top is exactly 1 larger than the bottom. Well, degree of the top is 4, degree of the bottom is 2, so it's 2 larger. So that means there is none. Let me write those down. Okay, HA, none. Slant asymptote, none. Okay, let me we're ready now for what comes after slant? Increasing, decreasing. So we're ready for our derivative. So let me erase some of this. Probably easier if I just wrote the problem down again, but it's kind of fun to not that much fun. Except when it blows up. Okay, there we go. So continuing on this problem, we got f of x is equal to x squared plus 1 over x squared. Well, I can take that x squared and move it up on top, and it becomes x to negative 2. Remember, when you move anything opposite where it's at in a fraction, the sign of the exponent changes. Now that'll make it easier to find the derivative. Derivative of x squared is 2x. Derivative of x to negative 2. We take our power, put it out in front, and then we lower it by 1. So that gives us 2x minus 2 over x to the third. Now this is the one we're going to work with when we go to find the second derivative. So let me write that down. Got f prime is equal to 2x minus 2x to the negative 3. Now I want to merge them into a single fraction for purposes of finding our critical values and the increasing, decreasing mins and maxes. So I'll rewrite the 2x as 2x over 1. Put them both in fraction form. We want to get our common denominator, which if I multiply these two together, our common denominator would be x to the third. Now our second fraction already has that. The first one, we multiply the bottom part by x to the third, so we multiply the top part by x to the third. And that gives us 2x to the fourth. Which then gives us, since we have the same denominator, we got 2x to the fourth minus 2 over x to the third. Okay, we got our single fraction. So we're going to set top part equal to 0. So we got 2x to the fourth minus 2 equal to 0. And we set the bottom part equal to 0. So we got x to the third equals 0. Well, x to the third equals 0. That just gives us x equals 0. Whenever you have a power and you got it equal to 0 like that, you can just drop the power and set x equal to 0. This one, I'll take the negative 2 to the right side, becomes a positive 2. Divide both sides by 2. And we get x to the fourth is equal to 1. Now x to the fourth is x to the 4 over 1. We're trying to get x by itself. You get rid of a exponent by raising both sides to a power equal to the reciprocal of it. So we're going to take both sides to the 1 over 4 power. Now since there's an even number up on top here, that means we put a plus or minus on the other side. So that's a plus or minus. Well, 4's cancel, the 1's cancel, we got x. A plus or minus, 1 to the 1/4, if I put that back in a radical form, would be the 4th root of 1, which would just give us x is equal to plus or minus 1. Now remember our critical values. We got 0 and plus or minus 1. Let me write down the 0 down here. So let's build our table of intervals. Okay, so we got x is equal to -1, x is equal to 0, and x is equal to 1. Clear over here is negative infinity. Clear over here is positive infinity. We want to choose test cases. Something between negative infinity and -1, like -2. Something between -1 and 0, like -0.5 or -0.5. Something between 0 and 1, like 0.5. Something greater than 1, like 2. Now we want to plug those into our derivative. What is our derivative? This right here. So I'm going to use a calculator to make my life a lot easier. And we'll plug that in. So we got, press y equals, press clear. And I'm going to put my f of x on, actually I'll just do this one. So I got 2x minus 2x caret -3. So that's my derivative here. Now I want to make sure my calculator is set up correctly, so I'm going to do second window to go to table setup, and you should see independent say ask. If it doesn't say ask, you down arrow to that line, right arrow, put your flashing cursor on the ask, and press enter one time. And then we want to go into table. So we'll do second graph. If you have numbers here, go ahead and delete them and clean them out. And we're going to plug in these values. So I got -2, enter, -0.5, enter, 0.5, enter, and then 2, enter. Okay, so -2 gives us -3.75, so that's negative, so it's decreasing. -0.5 gives us 15, which is positive, so this is increasing. The 0.5 gives us -15, so this is negative, so it's decreasing. And the 2 gives us 3.75, which is positive, so it's increasing. So let me write that down. It's decreasing from -infinity to -1. Then it's increasing from -1 to 0. And then it's decreasing from 0 to 1. And then it's increasing from 1 to infinity. Let me write that down on my piece of paper here. Decreasing -infinity to -1. Increasing -1 to 0. Decreasing 0 to 1. And increasing 1 to infinity. Okay. So those are our answers for the increase and decreasing. Now extrema, mins and maxes, which is H. That occurs where the changes from increasing, decreasing, if the graph exists there. So this is decreasing, changes to increasing, so this is a min. Now this one changes from increasing, decreasing, so we might think this is a max. We'll come back to that. And then this is decreasing to increasing, so this would be a min. Now I said we'll come back to that. If we go back to our domain, originally we said our domain, where a graph exists, we said x cannot equal to 0. It doesn't exist at 0, which means that we can't have a max here. If the graph doesn't even exist there, it's not a max. So we're going to have a min at -1 comma something, and we'll have a min at 1 comma something. Now we want to plug these back into our original function, and our original function was this right here, so let's put that into our calculator. So press y equals, press clear, and I got x squared, so x, then x squared, plus 1 divided by x squared. I do second graph to go into my table. I'll press delete a few times to clean all those out. And we're going to plug in -1 and 1. So -1 inner and 1 inner. Both of them give us 2. Let me write those down. Okay, min is -1, 2, and min at 1, 2. Okay, so I'm going to start a new page. We're ready to go on to concavity now. Okay, now remember, our f of x was equal to x squared plus 1 over x squared. Our first derivative was equal to 2x minus 2x to the negative 3. Now we're ready for concavity, I. So we want to find our second derivative. So we're going to continue on. Take derivative of this. Derivative of 2x is 2. Minus 2, take your power, put it out in front. Lower your power by 1. So negative 2 times negative 3 is 6. So we got 2 plus 6x to the negative 4. Now that's our second derivative. That's what we'll probably use if we have to plug it in the calculator. But to find our critical values, we need to get a single fraction. Because remember, x to the negative 4, that's the same as 2 plus 6 over x to the positive 4. We want to get a common denominator. And in order to do that, we both have to have denominators. So put the 2 over 1. Now our common denominator, we can multiply these two denominators together. And x to the 4th would be our common denominator. Now this one already has x to the 4th, so it stays as 6. Now our first one here, we multiply the bottom part by x to the 4th, we multiply the top part by x to the 4th. Now that they have the same denominator, I'm going to have 2x to the 4th plus 6 over x to the 4th. And we got our single fraction. So we're going to set the top part equal to 0. So we've got 2x to the 4th plus 6 equal to 0. And we'll set our bottom part equal to 0. So we've got x to the 4th is equal to 0. Now this one gives us x equals 0. So that's one critical value. This one, let's solve it. Take 6 over the right side. So we've got 2x to the 4th is equal to negative 6. Divide both sides by 2. And we got x to the 4th is equal to negative 3. Now x to the 4th, that's like 4 over 1. And we want to get x by itself, so we're going to raise both sides to a power equal to the reciprocal of this. 4 over 1, the reciprocal is 1/4. So we'll take both sides to the 1/4 power. Now since this is an even number, that means we need to put a plus or minus on the other side. Well, these 4's would cancel, the 1's will cancel, and we get x is equal to plus or minus, put this back in the radical form, and this would be the 4th root of negative 3. Well, we can't have a negative number inside of a radical with an even index, so there's nothing out of this one. So our only critical value is our first one we found, x equals 0. I want to build a table of intervals. Clear over here is negative infinity, clear over here is positive infinity. We want to choose test cases, something between negative infinity and 0, like negative 1. Something greater than 0, like 1. Now we want to plug those into our second derivative. But look at this right here. X to the 4th. When you have an even power, it's always positive. Up here we got x to the 4th. So that's always positive. 2 times a positive number is positive, plus 6 is still positive. Divided by a positive number is positive. So it does not matter what we put in there. It's always going to be positive. So this is positive, which means it's concave up, concave up. So this is concave up from negative infinity to 0. And this is concave up from 0 to infinity. Let me write that down. Concave up from negative infinity to 0. And then it's concave up from 0 to infinity. Now our POIs, that's J, I believe. You only have a point of inflection, a POI, if the concavity changes. These are both concave up, so that means there is no POI. Write that down. Okay, now I'm ready to graph. I got all the pieces of information. So let me see what I come up with. Okay, domain x cannot equal to 0. That tells us it doesn't exist there. No x-intercept, no y-intercept. Our vertical asymptote is x equals 0. X equals 0 is this right here. So that's our vertical asymptote. It's going to skim that at some point. Horizontal asymptote none, slant asymptote none. It's decreasing, okay, min, negative 1, 2. So negative 1, 2. That's going to be a min. Then our other one is 1, 2. So 1, 2. This is going to be a min. Okay, POI is none. Boy, we haven't got much information, have we? But our decreasing says it's decreasing from negative infinity to negative 1. And here's negative 1. So it's decreasing. Now I don't know how far out it goes, if it's this angle or if it's like this. I'll assume it's this close. Comes down here, it's the min. Then it changes to increasing from negative 1 to 0. So it's increasing, so it's going up like this. Since this is a vertical asymptote, it's probably skimming that, if I had to guess. And then from 0 to 1, it's decreasing, so it must be coming up here, skimming this, and coming down here, hitting this point. And then it's increasing from 1 to infinity, so it's gone up like that. So that looks like our graph there. Now let's actually graph this and see what in the world it looks like, according to the calculator. So I'll press y equals clear. And I got, actually I already had it in there, but x squared plus 1 divided by x squared, and then graph. And that does look like it. It looks like it goes a little bit further out than what I did, you know. But looks like that gives us our rough idea of what our graph looks like. So those are answers.